When Yellowstone erupts, we're all going to die. Well, maybe not all of us, but let's be honest, some people are just itching for the apocalypse. So, here's what scientists think really caused the three biggest volcanic eruptions in history. And at least one of them will surprise you. Number 3, Toba, Indonesia. The year is 74,000 years ago. Humans have yet to invent agriculture and live in small nomadic tribes across the world. Then, out of the ground in Indonesia, rises a supervolcano which has been brewing for hundreds of thousands of years. It explodes with the force of over 2,000 nuclear bombs vaporizing the top layer of Earth and leaving behind a crater so vast it would make Texas look tiny in comparison. In fact, the ash thrown into the air by the eruption was so dense it circled the entire planet. But despite the cataclysmic nature of the blast, there's evidence that humans barely even noticed. Most scientists attribute this to the lack of development, meaning no advanced civilizations were around to witness the event. But a recent study has suggested something much more sinister. By studying ice cores from the Siberian ice sheet, researchers were able to find layers of debris left behind from the eruption. What they found was shocking. The amount of ash in the ice from that particular year was 10 times higher than normal. But the year before that, the ash was already at abnormal levels. This suggests that the massive eruption was preceded by smaller explosions, which would help explain why there's so little archaeological evidence of the catastrophic event. Even more alarming is the fact that a second, smaller peak of ash can be seen right after the main eruption. This could indicate that the magma chamber responsible for the initial explosion was still active afterwards, meaning that the first explosion may not have been the largest. But if this is true, then where did all the extra ash go? One theory is that the first explosion actually caused the second, creating a chain reaction between the two blasts. As the first cloud of ash settled, it created a weak zone in the atmosphere. This allowed hot gases from the magma chamber below to rapidly expand upwards, causing a second and even bigger explosion. Another theory suggests that the second eruption was actually triggered by the first, because of a domino effect. Basically, the first eruption kicked up so much debris that it destabilized the crust above other nearby magma chambers, triggering the second explosion. But if that's true, then why didn't the first eruption trigger more than just one additional blast? Well, it might have. There's a third lesser-known theory that suggests the second explosion actually happened somewhere else. According to this theory, the first explosion in Indonesia created an atmospheric shock wave that traveled halfway around the world and triggered another super eruption in what is now Eastern Africa. If this is true, then this could explain the gap in time between the two smaller ash peaks in the Siberian ice cores, because the shock wave would have taken time to circle the globe. But there's also a problem with this theory. Scientists haven't been able to find evidence of a second explosion anywhere in the world during that time period. So it's possible that the second, smaller peak in the Siberian ice cores could have come from another source entirely. Perhaps the real reason there's so little evidence of this cataclysmic event is because it didn't happen in a single year. Instead, the entire thing could have been the result of multiple, overlapping events that took place over several years. But unfortunately for us, scientists don't have enough evidence to prove or disprove any of these theories, which means we may never know what really caused the Toba super-eruption. Number 2, Lake Kivu, Democratic Republic of the Congo. In 2002, scientists discovered something truly horrifying. Beneath the surface of Lake Kivu in the Democratic Republic of the Congo lies a massive pool of carbon dioxide gas. The pressure from the surrounding water kept the gas trapped underneath, but if it was released, it would create a cloud so thick and heavy that it could blanket the entire world. The amount of CO2 under the lake is equivalent to 300 billion tons. At this rate, the gas builds up at about 3 inches per year, which may not sound like a lot, but over millions of years, this slow build-up of pressure has created a ticking time bomb. That's because, at any moment, the gas could suddenly be released, either naturally or by human activity, killing everyone on Earth by suffocation. It's a bit dramatic, but not totally unrealistic, That's because Lake Kivu sits above a tectonic plate boundary where two continental plates are slowly colliding. The pressure from the collision heats up the surrounding rock, allowing fluids to seep into the cracks. These fluids then react with the surrounding minerals, releasing large amounts of carbon dioxide gas. But the gas doesn't stop there. It travels further down into the lake and becomes dissolved in the water. Over millions of years, this process has created a dangerous situation. At present, the lake releases around 100 tons of CO2 every day. But scientists predict that if the gas is suddenly released, it could kill off 10 million people within hours. Fortunately, however, there are ways to prevent such a catastrophe from happening, but it might require a very delicate operation. One way to get rid of the excess gas would be to simply drain the lake. But this would cause all sorts of ecological problems in the area. And let's be honest, it's probably not the best idea to divert an entire lake full of potentially deadly gas away from a densely populated area. Luckily, there's another option. Some companies have proposed building a system of pipes at the bottom of the lake to collect the gas and transport it to the surface. From there, the gas could either be pumped back into the lake or transported to industrial sites where it could be used as fuel. But this option comes with its own risks. If the pipes are damaged or break, then the entire lake could be thrown into chaos. But perhaps the most exciting solution is to harness the power of the lake for renewable energy. If carefully managed, the CO2 could be extracted from the lake and used to generate electricity. This process could provide a steady stream of energy for the local population while also reducing the risk of a catastrophic explosion. But even if everything goes wrong and the CO2 is suddenly released, there is a natural system in place to help mitigate the damage. In the event of a sudden release, emergency vents would open up at the bottom of the lake, releasing the pressure and allowing the gas to escape harmlessly into the atmosphere. Unfortunately, despite these precautions, scientists are still concerned about the safety of the pipes. That's why researchers are constantly working to improve designs and ensure the safety of the system. For now, however, there's only one thing we can do: sit back and wait, and pray that the deadliest volcano in the world never erupts. Number 1. Yellowstone National Park, Wyoming. If you've ever visited Yellowstone National Park, you may have noticed something strange about the landscape. There are an abundance of geysers, hot springs, and mud pots scattered throughout the park. These features are all evidence of the supervolcano that lies beneath the surface. In fact, the entire region is a hotbed of volcanic activity. The Yellowstone supervolcano is one of the largest in the world and has erupted several times in the past. Each eruption has had devastating consequences for the surrounding area. The most recent eruption occurred 640 years ago and created the Yellowstone caldera. But the biggest eruption in Yellowstone's history happened 2 million years ago and is still the subject of debate among scientists. Some believe the eruption was caused by a sudden increase in magma production deep within the Earth's mantle. Others believe it was triggered by the movement of tectonic plates. Regardless of what caused the eruption, the amount of ash thrown into the air was staggering. It's estimated that over the course of 3 days, the volcano erupted 2,800 cubic kilometers of ash, pumice, and other volcanic debris. To put that into perspective, the total volume of the debris is roughly equal to 10 Olympic-sized swimming pools. The explosion was so violent that it created a caldera over 43 miles wide and 36 miles long. But the eruption didn't stop there. In fact, it continued for decades, with smaller eruptions occurring all around the main event. These eruptions created layers of ash and pumice that stretched from Canada to Mexico. But despite the size of the eruption, there is little evidence of it on the surface today. Most of the debris has eroded away, leaving behind only a few small features. But the eruption didn't go unnoticed. In fact, scientists have been able to piece together a timeline of the eruption by studying the layers of ash left behind. They've been able to date the different layers and compare them to geological records from around the world. What they found was shocking. The eruption of Yellowstone wasn't an isolated event. It was part of a much larger volcanic eruption that occurred around the same time. Eruptions in Japan, Italy, Greece, Indonesia, and other parts of the world all seem to have been linked to the massive eruption in Yellowstone. But why were so many volcanoes erupting at the same time? Scientists think it may have to do with the movement of tectonic plates. As the plates shifted, it may have caused magma to rise up from deep within the Earth's mantle, triggering a chain reaction of eruptions, or it could have been a coincidence. Maybe all these eruptions just happened to occur at the same time. But whatever the cause, the eruption of Yellowstone 2 million years ago was one of the largest in Earth's history. And it's a reminder of the incredible power of nature. Now it's time for you to tell me, which ancient supervolcano eruption was the most interesting to you? And why? Let me know your thoughts, and thanks for watching.